Good morning, ladies and gentlemen, and this morning I have a treat for you. Let's assume that we're 1,000 years in the future and you've stumbled across two OM606 engines and you want to get them running and you'd like to know the basics of how to get them running. Well, I'm going to go through that right now. I was going to use this crate that's about to go out, but because the inlet manifold's on, it's probably going to be a little bit easier to use this second engine that I'm working on as you got a full view of the injector pump. So, injector pump is where we can get started. So these injector pumps are mechanical. Originally, these engines came with EDC pumps, apart from the early non-turbo ones, which did have mechanical pumps, but we'll not consider the non-turbo ones because they're kind of like the child that you would hide in the cupboard. Now, this fuel pump has a mechanical vacuum operated stop solenoid. So unlike lots of other mechanical pumps on the market that would normally have a single wire coming off them that you would apply you would remove a power feed to stop them, these require a vacuum to be applied to them to stop. So this little nipple on the top here, you would suck on it and this would pull this lever back and it would stop the engine, it cuts the fuel. Just like that. So, to actually make the thing run, to make it apply fuel, we don't need to put anything to it as far as vacuum or electronic or anything like that's concerned. We don't have to push the throttle lever forward, we don't have to do anything like that. The governor is going to take care of all that for you. Now, what we are going to have to put to it is fuel. As you can see, this engine and that one alike, they both have a mechanical lift pump fitted. Now, pretty much all the engines that you're going to see coming from me are going to have mechanical lift pumps on. And the reason for that is, even with our largest element designs, the efficiency of the element is so good. How do you say that without me sounding like I'm bragging about how good my own elements are? The efficiency of the design of the element allows the lift pump to be able to supply 500 plus horsepower, which can't be said for other elements on the market. How can I say that without suggesting I'm slagging off the competition? Because they have a lesser design. So, we're going to put fuel to it. Fuel line, straight from your fuel tank. So an 8mm internal rubber hose to this lift pump, because this is the sucky bit. Right, coming closer so you can see. This is the sucky bit, and then this bit is the out. So it's going to suck in here, and then it's going to pump out there, and it's going to send it up to here. Now, we swivel round, using the magic of me having two engines built due to my and my team members' hard work, and not just talking about it on the internet. I did promise I'm not going to rant about that. You can see here the fuel pipe layout. So fuel pipe would be coming in from the tank, fuel pipe coming out, and it comes up into the filter head and it pressurizes the filter head. Now generally that mechanical lift pump can be anywhere between 0.5 and 1 bar, and that then feeds back to the injector pump. The injector pump itself internally in this section builds up pressure, and then it builds up pressure because in the back of the pump would be a banjo with a smaller hole which allows pressure to build up, which then allows the elements to pump up through the injector lines and into the injectors. Okay, next thing you need to know. If one of these engines haven't been run, we're 1,000 years in the future for a while, you're going to need to crank it over. Now, you do not need to crack the injector lines to get any air out. That is not how this system works. This is considered a self-bleeding system. And the starter motors on these are designed to deal with that. So yes, they will crank for a while, but they do not need you to bleed them up. You don't need to be cracking any lines or anything like that. Just crank it and it will go. The only reason you may want to crack a pipe is just to see if there is fuel pumping out. Because at the end of the day, if we are 1,000 years in the future, the rack may have even jammed. The fuel could have solidified. But what I can guarantee is not many of the plastics will have perished. Not that I'm suggesting that any other engines on the market would have plastics that would fail and that I'm saying that they're lesser. I'm just saying that this engine doesn't have many plastics on it. So that's that covered. Now the next thing you're going to have to consider to get your 606 running is the glow plugs. Now 606s do not want to start without glow plugs. They're an indirect injection engine and they seem to have little to no capability of being able to start without a glow plug. Even when these engines are warm, they're a bit reluctant to start without glow plugs, but from cold, forget it. So what you need is a loom that connects all these together. Now, from memory, when I've made custom relays in the past, when I've been sort of bodging, I think from memory you need sort of upwards of 60 amps to power these. Don't quote me on that because I don't know what I'm doing. But we do sell a tried and tested relay. I believe it's from a Toyota application. It's a timed version, and that deals with them perfectly. But you do absolutely need it, unless you're going to use some sort of easy start or spray or anything like that, but obviously I don't condone that kind of behaviour. Now what else are we going to need to know? Oh well, let's assume you've got that engine running, you know, it's finally running, and you're actually going to want to start using it and taking it for a drive. And the first thing that people ask, well, second thing that people usually ask me is, where do I connect the vacuum lines? Well, when they say vacuum lines, they mean pressure lines, because of course there is no, with the exception of the stop, need for vacuum or vacuum coming from the inlet manifold of a diesel. So if you come round here, I'm going to discuss the pressure lines. Now on the injector pump, you can see down here we have this section here. It may be better to describe this on the other engine. Let's just swing quickly around to the other engine. So we have this section here. Now this is called the alder, and basically what happens is, as the turbo boost pressure increases, pressure goes into this actuator and it moves this forward like this. Now this particular system being much more stable and having a larger range than any of the other alder systems that people are using on the market, and it's stronger. You can't just push down on it and end up with like completely inaccurate fueling. And I'm not suggesting that the other alder systems on the market put on there by other pump builders are inferior. I'm not suggesting that they made one alder system 10 years ago and it still is inferior and they've made no effort to make it any better whatsoever and people are still buying into that, because that would be unfair. All I am saying is that this is a much more solid and stable device that does not deflect in that same way. Now, the thing to know about it is, if you have managed to get this engine running and it's working well and you're wanting to have a little bit of a tweak with the fuel, you need to make sure you've got your air pressure feed from your manifold, from the nipple on the manifold to here. Now it's pressure being the key word. We don't have any vacuum in the manifold. Assuming the pressure's going into there, and as the boost increases and it pushes this out, if you want to adjust this, very simply, if you want to adjust the low end fueling, so the off boost, so when no air pressure is going in here, it's a case of adjusting this screw. And if you move this screw that way, it allows that lever to come further forward, and that will make more fuel off boost, so you'll get more smoke. It may spool your turbo up a little bit quicker, but you're going to get more smoke off boost. These two screws here are going to do your on boost fueling, so the amount that this whole system can travel as a maximum. So if you move those two out, this will go further forward, and that will allow the rack to move further forward and create more fuel overall. So I think just to give you an idea, this pump from memory, I have the test sheet but not in front of me, is set 45cc on the off boost setting, and it will be, this is having a hybrid, so 100cc on the on boost setting. So 45, 100, and that will give you it'll give you a very solid 300 horsepower. Right, so swinging back to this one then. So we've got two fittings on here. as you can see. So one, we're going to put onto the actuator to feed that, to make sure that that works. If you'd left this off, if you were wondering what would happen if, because we're 1,000 years in the future and you can't get any hose anymore, what if you left it off? Well, what would happen is the actuator wouldn't move forward and you would only have off-boost fueling, which is 45cc. Well, to give you an idea, a standard Mercedes W124 with one of these pumps on it has 35cc of fueling. That's it. It doesn't have an on and off Alder. That's it. Mercedes claim 120, 115, 100, whatever it is horsepower. They make about 55, 60 realistically on a dyno. Not suggesting that they are obviously fibbing about that, but my testings show about 60 horsepower. So that will tell you, if you don't connect that pipe, that's what you're going to get, maybe a little bit more than that. You're going to get probably, what, 75, 80 horsepower. Put that pipe on, you're going to get a lot more. Right, so that's one. The other, you're going to wonder what the other pressure pipe is for. If we swoop onto the other side of the engine. So this particular engine is going out with a quick spool race turbo kit on it. So this is a turbo setup that's suitable for, I rate it at, with the small housing, just under 400 horsepower. Do you want me to move back a bit so it's easier? I rate this for about 400 horsepower. I say as an average 400 horsepower. Realistically, the small housing's going to get you 370, 380. The larger housing, the medium I call it, is going to get you into the ballpark of 420. Now, very, 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 very many years ago, we sold one of these setups to Goran over in Sweden. Goran, you know, my best mate. And he put it on an engine dyno, and the engine dyno showed 495 horsepower. So anybody suggesting that my figures potentially are high, yeah, theirs were a lot higher. So, and that was actually even on a manifold adapter. It wasn't even on a manifold. Anyway, I digress. I'm not suggesting what people are or aren't saying may or may not be true, because that would be absolutely ridiculous. And the fact of the matter is, me and Goran are actually good friends. Goran, what a great guy. I'm actually now taking the piss. Not out of Goran, but out of Fred. So, this here is the wastegate. Now the wastegate needs a pressure feed, and that's what that second nipple on that other side is for. Now inside a wastegate you have a diaphragm, and if you picture these two pipes, the diaphragm sits in between. So if we put, and this has a valve seat at the bottom, if we put the air pressure pipe from the other side to this bottom fitting, that allows the wastegate to open. Now the wastegate control, the set pressure, is regulated by a spring that's inside this hat. So underneath here there's a strong spring, and the strength of that spring against your boost pressure going in at this feed determines what the boost pressure is going to be that this setup can make. Because when the boost pressure overcomes the spring, this is set for 2 bar, so let's say that when this pressure gets to 2 bar, it will beat the spring and it will start to push the spring, and then the valve will open, and then the gas, the exhaust gas which is going into the turbine, will suddenly decrease, because obviously you're losing a load of it out the screamer pipe. The turbo will slow down, and then the gate will close, and it'll kind of make a chain reaction. Does that make somewhat sense, using this real life prop that I've spent a lot of time building and not just talking about? So, 2 nipples, one to the bottom of your wastegate, one to the other. You might be wondering what this other little pipe is for. That is for a additional boost controller. So if you wanted to add more boost pressure to this setup, you can actually feed into this top one, and that assists the spring, so that then raises the boost pressure. But my suggestion is keep that as a vent pipe, because 2 bar for this setup is absolutely perfect. Right, next essential for OM606 and you're 1,000 years in the future. You're going to want to know what oil to put in it. I like to use 5W40 fully synthetic. There is zero reason to use any really heavy oil, unless the engine is, of course, worn out and there's huge bearing gaps and tolerances. I don't like going down to the 30 because it's a bit thin. 5W40 fully synthetic is what I would advise. I can't tell you an exact quantity because all the sumps are different. This specific sump is actually over 10. The rear sumps are around 9. And there's absolutely loads of variations. But if you start with 9, check the dipstick, do it the old-fashioned way, people on a forum aren't going to be able to advise you. Before you start typing, just take the dipstick out. Oh, it needs more or it needs less. That's what I would advise. Right here, this is where we can take our oil pressure feed. So if you want to hook up an oil pressure gauge, sensor, light, whatever you want, take it from there. You can also take it from this little fitting at the back, but sometimes that can be an issue with the firewall. Then if you want to take a temperature reading, cooling temperature, onto this engine, we've got 2 little points here. This is where the factory takes it from. That's an additional if you want to use it, which leads us right onto this port here, right next to it. Now that is the outlet for the heater matrix, the cooling system for the cabin, and that goes round and links in to this side back of the thermostat housing. You can just see it there. Now, if you have managed to dig this engine out, and we are 1,000 years in the future, and you wanted to install it into something, you have to make sure that that coolant line with the back of the cylinder head and that is always connected. So if you have a cooling system in your vehicle, a cabin heating system, you need to make sure that when you turn that heating off, it never cuts that flow off between there and there, because the cylinder head needs that coolant flow around it, and you will get yourself into overheating issues and all kinds of things. So come on, we'll go over here and finalise. So the last thing I'm going to mention is how are you going to rev it up, because I don't think you need me to cover how to wire up a starter motor. Obviously we're in the future, and by that point we'll have wiring diagrams built into our brains. This is a throttle lever. Now the throttle lever obviously moves forward to rev the injector pump, the engine up, should I say, and it is absolutely critical to do 2 things. So you need to make sure that to get the maximum power from your setup, that lever moves fully forward until it touches the stop, until you can hear that touch the stop. And the other, probably more important thing is that lever comes back to the stop, because if it doesn't come back to the stop, you can end up with issues where the car won't come back down when you rev it up and other things like that. So it's absolutely critical that that throttle lever does its complete travel and nothing can jam it up or cause any issues. I think we've covered everything there now. And if you are 1,000 years in the future, well, I hope it's all still good, and bye for now.